A little trick if you're putting together a radio circuit using a trimmer capacitor. For those unfamiliar with trimmer capacitors, they are a type of variable capacitor whose value you'd typically only change occasionally. Applications in a circuit include as part of a bandpass filter, a matching network in a radio frequency amplifier, or a tank circuit in a free-running radio frequency oscillator. Radio circuits have a habit of being temperamental, and those with trimmer capacitors are particularly so. Even something like a metal screwdriver blade can introduce stray inductance and capacitance, and that can make adjustment harder, especially if you're trying to align a sensitive VHF receiver, transmitter, or free-running oscillator. Very often, one side of the trimmer capacitor will be earthed. Now, trimmers are normally not polarized, but I suggest connecting your trimmer in a certain way to make adjustment easier. Depending on how your trimmer is constructed, the part that you put in your adjustment screwdriver to vary the capacitance will be connected to one of these pins. The pin it's connected to should be the one that's connected to earth in your circuit. The reason why I suggest that is if you use a metal screwdriver as an adjustment tool, then that will not affect the operation of the circuit if it's earthed as much as if it was in contact with the active pin on the trimmer. To test which side of the trimmer is earthed, you just use a multimeter or audible continuity indicator, one probe on your screwdriver adjustment of the trimmer, and then you put the other probe on the other pins. You can see that the pin nearest the rounded side of the trimmer is the one that's in contact with the adjustment part. Therefore, when you insert the trimmer in your circuit board, the rounded part should be on the earthed side. There are some cases where neither side of your trimmer is connected directly to ground. In that case, the rotor part of your trimmer should instead be connected to RF ground. That's different from DC ground. You can tell that parts of a circuit are at RF ground by the presence of a capacitor to earth. It should probably be 10 nanofarads or more. Although you might put a multimeter on here and find that there is a DC voltage, there shouldn't be any RF, because as far as RF is concerned, a capacitor is effectively a short circuit to ground. It's good construction practice to ensure that trimmers can be adjusted even with a metallic tool. The easiest way to ensure that is to have the part of the trimmer that's in contact with the alignment screwdriver at ground potential if possible. That should be a DC ground, or if that's not possible, an RF ground.